Welcome to Math is Fun with Amajoy. Welcome to today's lesson. In today's lesson, we will be studying data presentation, analyzing data, and also probability. I know some of you must have heard about probability, and the most exciting thing about today's lesson is I'll be sharing some stuff about economics with you. As some of you may know, I'm an economist and I am so passionate about data. Today, we're going to learn something related to economics. So get your book and your pen and let's get to work it. Okay, so data presentation, analysis, and probability. Make sure you pronounce it well so that your lips do not roll. Probability. Okay, so what is data? Now this is not Ethel data, busy 4G data, self-line data. No, this is data in mathematics, and data can also be seen in statistics and, as I said earlier on, economics. So data is a collection of facts such as numbers, words, measurements, observations, or just descriptions of things. So all this a collection of data. This is how we can describe what data is. So now most importantly, numbers, measurements, observations. These are things that will be of importance to our study. So let's see. How is data collected? So we've been hearing data. Today, data on this, data on the number of patients who are suffering from COVID-19, as we've been hearing. So today we hear 30 cases, tomorrow 50 cases. That is collection of data. So how do they collect those data and present it to us every day in the news? How do they come up with figures every day? Oh, the number of students in your class at this. How do they come up with it? The number of patients with mild symptoms of COVID-19 is 18. How do they come up with this? The number of cases in the whole world is about over 1 million. How do they come about this data? So now let's see. It can be collected through questionnaires. Data can be collected through questionnaires. So what is questionnaire? So questionnaire is a set of printed or written questions with a choice of answers devised for the purpose of collecting data. So they can collect those data by printing or just creating a questionnaire. So I don't want to lay emphasis on printing because now the world is going digital. And so we have digital questionnaires which you can fill online. So these questionnaires come in a form of questions. So I'll get one and then paste it in the Google Classroom for you to get a feel of how a questionnaire is. So I'll try to paste one that I designed myself. So I try to ask people about their perception on African fashion. So kente, fugu, the northern print and all that. What's their perception on it, and will they like to sew it? Will they like to buy one themselves? So I'll just paste a link to a questionnaire I designed on that. So people's willingness to pay for a particular African fashion. So I'll paste a link on that so that you would see how a digital questionnaire is. So it's a set of printed or written questions with a choice of answers devised for the purpose of collecting data. So I really don't want to delve too deep into questionnaires because it has so much information because we have different types of questionnaires. So this is narrowing it down to questions with choice of answers because I have some questionnaires that are open. I don't have, it's not like, okay, so a questionnaire is just like your end of STEM exams, end of trimester exams, sorry, where you can have objective questions. So I have multiple choice answers. You would be required to choose one of them. And we also have the section B part where it's an open it's an open question. I'll ask you to state and explain something so that I'm not giving you a set of answers or answer choices. You would have to bring your own answer. So a questionnaire can also be in that form. So I have a place where I ask them with my own answers. I want them to choose one. And then there is a place where they'll be required to answer by themselves. Okay. So data can be collected with questionnaires and also interviews. Okay. So in the news, we hear this that is happening in the northern region, this that is happening in South Africa. So what do? We call probably the health minister if it's related to health. Can he give us figures of what we are hearing? How many people are being infected with this? He gives us the figures. So with this, we are getting it through interview. So we are calling on an expert to give us figures related. So with the figures, we are able to see the gravity of the situation. When Ghana recorded just 2 cases of the COVID-19, we're all relaxed. Oh, it's not that serious. But when the data came and we saw it there increasing to a certain number, then the fear and panic came. Okay, let me not use Ghana. I'll use China. I myself am a victim of this because when it started coming, oh, 12 cases, just 12 cases in China. At least it's only in China. That was what the data was saying. Just 12 cases in China. So I thought it wasn't that serious because the data has given me a clear view of how intense the situation is. Until it started rising. So today is 500, tomorrow is 700. It's increasing, it's spreading to other countries. So now we are seeing data from other countries. So now it's showing me a picture of how intense the situation is. So now you see the importance of data here. And we are in Ghana and we are able to know what is going on somewhere. This can be done through interview. So we can call in an expert in another country, interview them on the situation, and then they tell us how intense or how mild the situation is through figures. Okay. So it can also be done by observation. So this um this data, this example of data happened once in my university because the civil engineering students, so they're engineers, they're training them to be engineers, but they were asked to go and gather data by observation. So all what they did was, so what they were instructed to do was to take a book and a pen and then go to the roadside and then count the number of cars that are passing the road, the Aflao road between a certain amount of minutes or hours. So let's say within 30 minutes, how many cars passed. So that they are observing the situation. So okay, now 2 cars have passed, 3 cars have passed. They are not asking anybody anything. They are not interviewing anybody. They are just using their eyes to see what is going on. So they are observing the situation and then they are gathering the needed data. So data can be done through observation. Okay. Then experiment. So this experiment, it's mostly used in the scientific field. So in science, they conduct certain experiments to see what the outcome will be, and then they record it. So when the experiment is conducted, the results we get, the recording becomes the data. And also databases. So with databases, I have a stored information somewhere. It might not be me, it might be, let's say, the number of students that graduated or the number of students that came out with A in 2015's BEC. That's a long time. I can't get that data. 2015 is a very, very long time, but a database will have it stored. It can be on a system, let's say on a computer, or it can be in a folder somewhere or in their archives, anywhere. So far it's in their database, so it has been stored there for future reference. It's not something I have with me. It's a database, and now most database economists use, we have we have so let me just share with you databases. It's I know it's far above your level, but it's just nice you know what it is. I know you've heard of World Bank. So World Bank have their database stored, so we can get them from WDI. Then we can also get data from Bank of Ghana. So Bank of Ghana, they have their database. Bank of Ghana. So let's just say I feel like writing. That's why I'm writing this. So Bank of Ghana, they have their database, and Ministry of Education. So as I said, the number of students that came up with A in the 2015 BEC, Ministry of Education can have their database. Ghana Health Service. So the cases of COVID-19 we are recording in Ghana, years to come, by then some of you will be doctors, some of you will be pilots, some of you will be economists like myself, and you would need this data to see its impact on something. So you would have to go. I don't have it in my hands now because I don't really need it. I might need it in future. So I'll just have to go to GHS database to get the cases of COVID-19 that was recorded per month or per week. They would have it stored in their database. So the database is just like a storehouse or their archives. And electronic too, like as I said. So the databases can be electronic. So we have WTI. Or the media, we can get data from the media. So media, today I listened to the news. This is what I heard. The internet is also a good media. So anything media related, newspaper, magazine, they're all media. So we can get data from there and then use it for our presentation. Okay, so here is one way data can be used. We've all heard, or some of you have heard, meteorologists. So they are scientists that study weather. They record weather data over days, months, and even years. It's important that they display this data for us to understand. I don't understand the meteor terms, so they would have to put it in a way that me as an economist will understand, me as a grade 6 student will see this data and then understand. So this is one way data can be used. So with this, they're able to tell us that it's going to be very cloudy today because they followed a pattern. They've gathered data over a certain period and then they're able to make predictions with it. They can also look at they can also use this data to inform farmers on their farming decisions. Okay, so plant this crops at this particular time because the weather was like this over previous years, so we are predicting the same thing is going to happen in future. So when you do this, they will present it in a way that you understand, and that is what we'll be learning today, how to present data in a simple manner for every layperson to understand. Okay, so when we are presenting data, we have, so I would want you to, I hope you're taking notes. If you are not taking notes up to this stage, I would want you to turn off the video and start all over again and start taking notes because it's very important. I'm giving a lot of information I would like you to write. Keep in your database for future reference. Okay, so this is one way we can present data. So we can present data in a graphical form. We can present data in a tabular form. So we can present data not only in graphs, and we have charts also. So like pie chart, pie charts, bar charts, all those charts. So either in graphs or charts, we have tables. We can present them in tables. And then one more thing we use in economics. This is a bonus for you. It's shadows or equations. Did I say shadows or equations? I want to say just equations. Sorry. So equations. I already have the shadows here, so okay. So some of you have watched my video on algebra and algebraic expressions. So if you haven't, you should go and watch it now, and you will understand how these equations work. So with algebraic expressions, we have it's like a guideline for you to develop an equation. An equation, I think I made mention of it in the video, that when an equal to sign is introduced in an expression, it becomes an equation. So if I have my a here plus is equal to y. So this is an equation you would see very, very often in economics. But this is an algebraic expression. This is an algebraic expression. So this can be, so I can rewrite this as, so I'm going to represent this a with values. So let's say 5 plus 2x is equal to y. So this equation here has been represented like this. So data will help us fill in this and then get a value for y. So in algebraic expressions, when x, so let's say when x is equal to 2, meaning you just replace this x here with 2. So 2 times 2 will be 4. 5 plus 4 is 9. So meaning y is equal to 9. So y could be anything. Y could be your supply function. Y could be anything. I don't want to go into detail in economics. So this is just a way of representing our data. So for your level, we'll be focusing on this graphs and tables, and then later in future we'll deal with charts. For equations, we'll leave that to grow. Okay, so now let's look at this graph, this beautiful graph here. What does this graph show? Please don't tell me COVID-19 data. Because we are looking for a way to flatten this curve. So this this is just, it's going, so this title here would help us know what it shows. So what you will need to look out for, what we need to look out for in graphs is the title of the graph, then the label, this labels on the x-axis, this is the x-axis, and this is the y-axis. This is the y-axis. So with the x-axis, you would have to check the labelings there. So this is month, fine, and this is temperature. And the title is telling us monthly high temperature for what? It's the name of a country. Okay. So all what we want to know is monthly high temperature. Okay, so since this is the monthly high temperature for, let's say, Ghana, that's the name. So for Ghana, they said, what does the graph show? Yeah, monthly high temperature for Ghana. How do the highest temperatures in May and November compare? So now, since this is month, J is for January, not joy. F year, February, March, April, May, June, July, August, September, October, November, and December. Okay, so this, let me change the color of my pen. So this data here shows us the monthly high temperature. So this axis here is for temperature. This axis here is for month. So they said how, so we've already gotten what the data shows. So it shows the monthly high temperature for hypothetically Ghana. How do the highest temperatures in May? So May, this is May. What was the highest temperature? So May, you just trace it to the curve. So this is the curve. This is the curve along a springy curve. So you trace it to the curve. When you trace it, where it hits the curve, you trace it to the corresponding y-axis. So yeah, the intervals here are it's so this from year to year is 8. So in between it, this is half of it. So year will be 4. So the highest temperature in May is 4. So May is equal to 4. What's the highest temperature in November? This is November. This is November here. So when you look up here, nothing is here for it to hit the curve, but something is here down. This curve comes down into the negative part. So it's just like a number line. So this is 0 here, but beneath it here. So we said in our previous lesson on integers, we said after 0, we start entering into the negatives. Yes, that's the same principle here. So this was 0 here. So yeah, then the temperature entered negative. So here is negative 4. Oh, just wipe that off. Doesn't look so nice at all. Okay, so we just trace it down here. This is the curve. We trace it. So it hits this, which is -4, right? It hits it here. And we know in the European countries the temperature enters -10, -8, -4. So it's very, very normal, but very, very abnormal and unlikely in Ghana for us to even hit 16 degrees. No, no. So this is not Ghana, although yes, this is not Ghana, but hypothetically we are just assuming it is Ghana. So in May, the temperature was +4, but in November, the temperature is -4. Yeah, of course, November is approaching the winter season. So they said, how do the highest temperatures in May and November compare? So what we'll simply write is in May, the temperature was +4, but in November, temperature was -4. So don't forget the degree Celsius. So in May, the temperature was in Ghana was +4 degrees Celsius, and in November, the temperature for Ghana was -4 degrees Celsius. So that's how they compare. Which months have the same highest temperature? So how do we get that? Which months have the same highest temperature? So the easiest way of doing it, if you don't really see it, is for you to get all the temperatures. So let's start with January. So one secret about me is I'm not able to spot things when they're all jumbled up unless I arrange them and then I see I see what I'm looking for. So I'll have to put you through that. So January. So for January, if we trace it down, we get this. Yeah. So that is around, let's see, this is 8 plus 4, yeah, will give us 12. So let's say 13. January is 13. It's not drawn to scale. We're not using a graph sheet, so it's not going to be very accurate. So February. So February is, yeah, it's normal. So we have 12 there. March. March, what do we have? March is, yeah. So it's around 1. April. January was negative. Negative. Thanks for spotting that. So January was negative because it came down beneath 0. Wow. So in March we have positive now. So as I said, this is a European country because in January they are still in the winter season, and so temperature is freezing cold. So February is also freezing. 12, negative 12. That is cold. That is cooler than ice. So M, that is May. May we have 1 degree. It's positive now. April, it came to negative in April. This is the point here. It's negative. So when we trace it, we can get about 2. So negative 2. May. So example for April. May, let's see May. May, we've already done it here. We said it's 4. June. June is here, which is 24. Wow, June was really, really hot. That's summer. July. July, it went to about 25. July. I guess this is, I guess we trace it here. That's about, that's the 18. And yeah, so 8, 12, 13, 14. So let's say 14. So that's September. 14. October. But the weather really dropped and it came to about 5. This is above 4, so 5. Then November was when we had negative 4. So November is December. December was here. So let me wipe this off so that we can draw the. Okay, so I lost all my ink annotations on this slide, but you can refer back so you can reverse to go and see what was on the slide before. So from what I was able to gather, so as you've been following this slide, this January year and December, will give us the same thing. If you trace this, we'll get the same thing. So we've answered this question. How which months have the same highest temperature? So that is January and February. So they said we should write 4 other questions you can answer from the graph. So I would want you to do that. What other questions can we ask or answer from the graph? This is just something you should research on. So questions we can ask from a graph. So I just want you to research on it. It's not going to be graded, but for your own knowledge, I want you to do this. Okay, so in this slide, we have the graph shows the number of people that own a certain color car, number of men driving each color car, number of women driving each color car. So we have the y-axis and the x-axis. Y-axis, x-axis. You know, I told you that when you have a graph, all what you need to do is to check the headings, and then check the x-axis and the y-axis, the x-axis and the y-axis. So from the look of things, they both have the same y-axis. So this graph shows the number of people that own a certain color car. So this is for men, this is for women. So that's how we should show this information in a two-way table. So two-way table could be like this. So here will be for number of women. Ladies first. Number of men. Then I would like to bring the color first. This is easier. So color here. So the color, I'll just do red, blue, green. So this axis here was omitted. So the y-axis is the number of women. Here is number of men. So this is why it's a two-way table. It's a two-way table because they both have the same x-axis but different y-axis. So this y-axis here is for women and this y-axis here is for men. So we'll have 1, 1, 2, 3 colons instead of the normal 2. This is the normal 2 we have, but we are having 3 instead of 2. So when we have 3, it becomes a two-way table. So in that case, let's see. So for red, how many men were driving red? So we just look for, so mind you, this is a bar graph. So this is 12. So number of men, 12. For red, number of women was 7. Now let's see blue. Just change my color. So for blue, number of men was 8. Number of women for blue, oh, was also 8. For green, we have 3 for, this is in between this and this. If you trace it, it's halfway. So 3. Number of men was 3. Number of women, we had 5. Okay, so you would have to complete the rest in your book. How many people? So when you complete this, you're sending it to me. Everything you have to complete in your book, you're sending it to me. So how many people were surveyed? How many people were surveyed? So what you would have to do when you're done solving all the numbers you get for women, you find the total. You get the total number of women. You do the same thing, all the numbers for men, you find the total number for men. So addition of men and women will give us the total number of people that were surveyed to get this data. As simple as that. Simple. Data analysis. Simple. This is analysis of data. The data has been presented in a bar graph or a bar chart. And so we are analyzing what has been presented. So this is how economists work, even though we go more into details in data analysis. But these simple things are what we come to explain to you to understand, because when we start going deeper, you won't be able to get us. So for you to understand, and also meteorologists, when they want us to understand their concepts, they just present it in this simple chart representation, and then people will come and analyze it. So because this was this is that, that is what we've done here. That's what we are doing. We're analyzing the concept. Okay. So let's explore something else. So this is going to be really, really fun. So in this exploration, we'll need a paper cup or a styrofoam cup or styrofoam, anyhow you pronounce it. Which way is the cup most likely to land when it falls? So you have to put a cup on this table in your homes. Please don't use a ceramic cup, a mug, or any breakable cup. Please don't use a breakable cup. Use a disposable cup most preferably. So a paper cup or a plastic cup. Anyone that can't break. So you put it on this table, then you let it fall on the floor. So when it lands on the floor, because it's going to be a paper cup, it's going to be easy, it's not going to bounce, so it's going to fall as we want it. So when you use a paper cup, when it falls down this table, how is it going to land? So do it about 50 times. So the first, so you draw this position, so it's going to land probably like this. In a, if it lands on its body, it lands upright or it lands upside down. So one of these ways. So when you throw this cup, we want to see how it's going to land on the floor. So if it lands this way 3 times, the tally, you just draw your tally like this. Tally is just stroke, and which is total of 3. When you throw the cup 50 times, if it lands 3 times, you record this. If it lands upright, and it's about 6 times it landed upright within the 50 throws. This is how we do the tally. 4 strokes, the 5th one is going to cross them, and then you start again. Okay, so if it lands downwards, let's say 15 times, no, let's say 12 times. So I'll do the same thing. So we have 4, then the 5th one, stroke, stroke. So this is 12. This is 1, 2, 3, 4, 5, 6. This is 6. But I think if you use a paper cup, your result should give you, everything you will get will be equal to 50 because you throw it 50 times. But for me, I didn't throw any cup yet. I am sitting down here instructing you to throw it, but I'm showing you how you should present your data. So when you do this, this is what we call data presentation. You're presenting it in a schedule form. You know, I told you can present it in a tabular form. So it's either you present it in a table, it's called table or schedule. So this is how you're going to present it. So do you think the results will be different if you rolled the cup off the desk? How could you find out? So we really don't need this. I just want you to do this. Just fill in the table with this. So show and share. So compare your results with those of other pair of students. So this result you get, you're going to take a picture of it, your table and your drawing. So I want you to do it really nice. So this is the drawing, this is the drawing, this is the drawing. Do it really nice and then take a picture of it. If you're unable to upload it in the comment section of our Google Classroom, send a picture to me and I'll upload it. Then we'll compare it and see how other results were. So we would want to see how other people, what other students got. We'll compare it and see how different it was. So when you do that, you tell me the kind of data collection this is. How are we collecting this data? Is it through questionnaire? I don't think so. Is it through interview? No, we are not interviewing the cup. Is it through database? No, definitely not. There is no database on how a cup fell. So how are we collecting this data? I want you to send that to me whilst you send the results and then we'll post it. Okay. So now probability. 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 So this is part 2 of our previous lesson on data analysis and presentation. So now we are going to see the probability aspect. And I'm so excited because this aspect of probability is really easy. And it took me a long time to realize how easy probability is or was. So probability is the branch of mathematics concerning numerical descriptions of how likely an event is to occur. The chance of an event happening ranges from 0 to 1. So let me take this. Too much details. Too much details. So probability. Probability is a branch of mathematics concerning numerical descriptions of how likely an event is to occur. It's a branch of mathematics, not English language. I know you've been hearing, what's the probability that it will rain today? What's the probability that it will rain today? What's the probability that I will meet my friend when I get to a house? So we all use it in our daily lives, but now we want to see it in the mathematical aspect, so that when we ask ourselves what is the probability of this going to happen, we have figures backing it. So most of the time, probability happens after we've gathered our data and presented our data. Then we'll see the probability of an event occurring. So this we are going to use numerical description. If you're talking to your friend, what is the probability that it will rain today? What's the probability that the watch seller will come today? Your friend will tell you, I don't know. That is not backed by numerals. So in this probability, we'll be backing it by numerical description. So from the data we've gotten, what is the probability that this particular thing will happen? So now let's see something interesting. The chance of an event happening range from 0, which is impossible, to 1, which is certain. Okay. So now so the probability that the watcher seller will come, if it's 0, meaning it's impossible, she is not going to come. And if I say the probability that the watcher seller will come today is 1, meaning I am very, very, very certain. I saw her cooking the watcher. I saw her packing the things. I've seen her almost getting close to her watcher stand. So that the probability becomes 1. Okay. So a chance of 1 over 2 represents an event where there are 2 possible outcomes and each is as likely to occur as the other, like tossing a coin. Okay, so we'll come to tossing a coin, but let us see probability of an event happening, the formula. So probability comes with a formula. So the formula is number of desired outcomes over total possible outcomes. Fine. What is the probability that I would go to church? What's the probability that I will go to church this week? I don't know because you're not in my house. Okay, so number of desired outcomes. So okay, then I'll sit down and think. I go to church on Wednesdays and Thursdays and Sundays. Then what is the total number of days in a week? 7 days. So number of desired outcomes is 2. It's a desire for me to go to church twice. I can go to church every day, but I go to church twice. So the probability of me going to church would be 2 days out of the total number of 7 days. Fine. Too much information. Let's go to the next slide. For example, I know most of you play Ludo. I'm not good at Ludo. I'm actually not good at any board game. I'm not good at chess. I think because I've not tried it. I'm not good at chess. I'm not good at any board game, but it's really good because when you do that, I will be able to do it because I know I have knowledge of it in mathematics. So since you already have knowledge of it outside mathematics, this concept is going to be so easy for you. I know some of you play Ludo, you play chess, you like board games. Yes. This concept is going to be really interesting for you. So the probability of rolling a number greater than 4 on a 6-sided die. Of course, a die is 6-sided. Our Ludo die is 6-sided. It's in this. So for those of you like me that don't like board games and have not played board games before, this is what a die is. So we say 1 die, 2 dies. Not die as in die, but die. It's a die. So we have a die. It's 6-sided. For those of you that don't know, it's like this. One side is like this, another side is like this, another side like this, like this, like this, and like this. So this is my die. No, I don't have a die. I don't have a die because I don't play Ludo. I don't play games. I think there are other games aside Ludo that you use die. Yes. I don't play board games. Yeah. So for those of you that don't know what a die looks like, this is how it looks like. It's 6-sided. So because it's 6-sided, each side has its numbering. So 1, 2, 3, 4, 5, 6. So you should get a die or go find a video on a die if you've not seen a die before. Yeah. I know 90% of you have seen a die. Or 99%. The 1%. So the probability of rolling a number greater than 4 on a 6-sided die. So we said in a 6-sided die we have 1, 2, 3, 4, 5, and 6. 6-sided die. 1, 2, 3, 4, 5, 6. It looked incomplete. Okay, so the probability of rolling a number greater than 4 on a 6-sided die. So look at something. I'm tossing a die. Do we toss a die? No, we roll a die. It's my turn to play. I have to roll a die to be able to play. Then I think, what's the probability that I'll get a number greater than 4? Because I think the higher the number you get, the higher your chances. Something I don't know the rules. So, yeah. If you get a number greater than 4, so it's going to be greater than 4. So 4 is out. So how many numbers are left? So 5 and 6. So it's either I get a 5 or a 6, 2. So two numbers are after 4. It's either I get a 5 or I get a 6. Either I get a 5 or a 6. That is 2. Two numbers. 1, 2 numbers are left. Out of how many numbers am I supposed to get? So the chosen ones are 5 and 6. Out of how many numbers in total? So the total number of outcomes I'm supposed to get is 6. Now let's go back to the formula. It's a number of desired outcomes. The desired outcome I want is, Lord, please let me get a number greater than 4. What is the probability that you will get a number greater than 4? 5 and 6. 2. 2 times. So it's only 2 chances, Lord. It's only 2 chances for me to get a number greater than 4. I can either get a 5 or a 6 too. Over the total number of possible outcomes. So how many outcomes were you supposed to get? 6. And out of it, I'm getting 2. I want 2 out of this total 6. This 6 is 1, 2, 3, 4, 5, 6. And I'm selecting just 2 of it, 5 and 6. So that is 2 over 6. So this is the probability that I will roll a die and get a number which is greater than 4. So they said since there are 6 possible outcomes, 2 of which are desired, I get 2 over 6. And note one thing, this fraction can then be simplified. You see how mathematics is? Now fraction has come to play in probability. Who would have thought so? You thought after fractions as a topic you wouldn't need it again. But here we are in probability. Fractions has come to play. So this is 2 goes here 1, 2 goes here 3. So we can also say 1 out of 3. So the next time you play a board game that involves that and someone asks you, so what's the probability that you get a number that is greater than 4? Probably you've always be getting numbers less than 4. So what's the probability that now this time around you will get a number greater than 4? That is 2 over. So you just quickly do the calculation in your head. 2 over 6. This is something that happens every day in our house. So now you should start infusing mathematics into it. So 2 over 6. So what's the probability that you get? So now let's see something. What's the probability that you get a multiple of 2? What's the probability that I get a multiple of 2? So this are the possible outcomes you can get in the die. So multiples of 2, we have 2, 4, 6. So we have 2, let me change my color. We have 2, we have 4, and we have 6. That is how many? 3. So it's 3 desired outcomes. I want a multiple of 6. So the next time you play a die, I want to get a multiple of 6. What's the probability that I will get that? So that will be 3 times over the total number of outcomes you could get. That is 6. Cancelling this, 1, 2. So 1 out of 2. Sometimes, to show you're very, very smart, 0.5. To show you're super, super smart, 50%. Okay, so fraction form is fine. It's fine by me. Okay. Now, this is a task for you to do. Now, I left something out. See something. What is the probability of rolling a 1 or a 3? This is a bonus question. What is the probability of rolling a 1? So what's the probability that I'll roll 1? That is 1. Because I have only 1 in, between 1 and 6, I have only 1. So 1 out of 6. 1 out of 6. Or a 3. How many times can I get a 3 between 1 and 6? Only 1. I can get 3 only once. So that is 1 out of 6. So in this case, what next do I have to do? In probability, or means plus. So you should write this down. You will need it in high school. Or means plus and means multiplication. So if the question was what is the probability of rolling a 1 and a 3, would have multiplied this. But since it is or, just put your multiplication. 1 over 6. 1 over 6. Sorry, addition. Yes. So all means plus. So this gives us, they have the same denominators. So we can just add the numerators, which is 2 over 6. Which is the same as 1 out of 3. Final lines are as simple as that. Probability is so simple. I didn't know this when I was in grade 5 that probability was this simple because I don't know, probability. Why should I be solving probability? Why? It's English. No. Now I've seen the beauty of it. It is so simple. Yes. Keep applying it in your daily lives. So, and we'll be going into details in the course of the semester. Sorry, I keep on saying semester. Trimester. So, in the course of the trimester, we'll be going into details, the data analysis and probability, and then we'll have loads and loads of fun. Thanks for watching this video. Don't forget to comment, leave a comment with your questions. Let me know if you understood the concept, if you need further explanations, and I'll be glad to help. So we meet again. Bye bye.